Good morning, students. Today we are going to discuss the problems on DTFT. So, what different tools are available to analyze the continuous time signal, discrete time signal? If the signal is a continuous time signal, then there are some tools are available. First one is a continuous time Fourier series. Second one is continuous time Fourier transform, Laplace transform. When we can use continuous time Fourier series means if the given signal is a periodic signal, then we can use continuous time Fourier series. Suppose if x of t is a non-periodic signal, then there are two tools are available. First one is a continuous time Fourier transform, Laplace transform. This all we discussed in the last class. So next one, if the signal is a discrete or digital signal, that means x of n, then there are three tools are again available. First one is DTFS, discrete time Fourier series. If the signal is periodic signal, if the signal is a non-periodic signal, then two tools are available. First one is the discrete time Fourier transform and jet transform. In general, the DTFT, discrete time Fourier transform of any sequence means because it is a discrete and taken as a sequence, is given by DTFT of x of n is equal to, because it is a discrete signal, I am using the summation symbol, summation n equal to minus infinity plus infinity x of n e power minus j omega n, that equal to, because I am applying DTFT for discrete, the result will be in terms of frequency j omega, capital X of e power j omega. Then inverse discrete time of a x of e power j omega is given by inverse DTFT of x of e power j omega is given by f inverse x of e power j omega, that equal to x of n, that equal to 1 by 2 pi some integral minus infinity plus infinity x of e power j omega into e power j omega n and d omega, because integration I am using the integration with respect to d omega. So that is DTFT of discrete time signal is given by x of e power j omega, that equal to summation n equal to minus infinity plus infinity x of n e power minus j omega n. The inverse DTFT of x of e power j omega, capital X of e power j omega is equal to x of n, that equal to 1 by 2 pi so integral minus by 2 plus pi x of e power j omega into e power j omega n into d omega, because it is an integration I am using d omega. This is a, if it is a DTFT, e power minus j omega. If it is inverse DTFT, it is e power plus e power j omega n. Now we'll see what is the conditions or what is the convergence of a DTFT. For example, if you want to apply DTFT for some sequence, then what is the condition? This condition is a sufficient condition but not the necessary. So sufficient condition for existence of DTFT for a aperiodic sequence is given by, I am going to give small derivation part. I am taking the signal x of DTFT of x of n is equal to x of e power j omega, that equal to summation n equal to minus infinity plus infinity x of n e power minus j omega n. Take the modulus on both sides, then you will get a mod x of e power j omega is equal to n equal to minus infinity plus infinity mod x of n into mod e power minus j omega n. In general, we know mod e power minus j omega n is equal to mod cos omega n minus j sin omega n, that equal to 1, because cos omega n square plus sin omega n square equal to 1. So mod x of e power j omega is equal to summation n equal to minus infinity plus infinity mod x of n. Mod x of n is nothing but given signal. If the summation, the summable value is less than infinity, it may be positive value or negative value, then there exists a DTFT for a given sequence. This is the condition for existence of, this is not a necessary condition, this is sufficient condition to exist DTFT for a given sequence. Now we will see some problems on DTFT. Find the Fourier transform of the given three signals. First one is a del of n, this is the impulse sequence, u of n, step sequence, a power n into u of n, where the condition is important. If a is less than 1. In the problem itself they given a value is less than 1. First we will see one by one. General formula: Fourier transform of given segment del of n is equal to summation n equal to minus infinity plus infinity. Given signal del of n into e power minus j omega n. In general, we know the del of n impulse sequence equal to 1 whenever the inside value n value is 0. That means del of n equal to 1 when n is 0, otherwise its value is 0. So summation n equal to minus infinity del of n e power minus omega. Del of n equal to 1 when n equal to 0. That n equal to 0 is available within this minus infinity plus infinity. That's why that's value equal to the multiplication of del of n is e power minus j omega n at n equal to 0. Put n equal to 0 in e power minus j omega n. Then we will get one value. Next one. Find the Fourier transform of second one is a u of n. U of n is a step sequence. So general formula: the given sequence summation n equal to minus infinity plus infinity u of n e power minus j omega n. This u of n will decide the lower limit because n is a positive. If u of plus n, if it is a plus n, it will indicate the terminating point is infinity. To find the starting point of plus n value, equate n greater than or equal to 0. That means u of n equal to 1 when the inside value is always greater than 0. So n greater than 0, otherwise its value 0 for n less than 0. So this u of n equal to 1 when n greater than or equal to 0 means the summation symbol, otherwise the limits is going to change. Previous case it is n equal to minus infinity plus infinity. Here it is n equal to 0 to infinity. Then u of n equal to 1 e power minus j omega n. I am going to write this entire summation as a, because n is a positive value, 0 to infinity means positive. This e power minus j omega n I am going to convert it as a something power n. That means n equal to 0 to infinity e power minus j omega whole power n. Always try to get whole power n. Not only that, check the summation is always positive. N equal to 0 to infinity is a positive something power n. Then we studied in a plus 1 plus 2 or BTech level some formulas. For example, if n equal to 0 to infinity r power n, replace n equal to 0 r power 0 1. When n equal to 1 r power 1 r plus r square plus dash dash up to infinity. This is the formula. When it is n equal to 0 to infinity r power n, then the formula equal to 1 by 1 minus r. Condition is if r is less than 1 or mod r is less than 1, then only this formula is applicable. That means if we add all these values 1 plus r square plus dash dash up to infinity, we will get finite value. Then only this formula is applicable. This 1 is nothing but first term. First term is, it is the first term divided by 1 minus r. R means second term by first term. R by 1, otherwise r square by r, you will get r. So first term divided by 1 minus second term by first term. This is general formula. The same formula I am going to use here. N equal to 0 to infinity e power minus j omega whole power n, that equal to 1 by 1 minus e power minus j omega. So I am going to make this one as a formula, because I am to find the inverse DTFT. I am going to use this formula. That's why I make it as a bracket. With a bracket, make it as a formula. The Fourier transform of step signal is always 1 by 1 minus e power minus j omega. Third one, Fourier transform of a power n u of n. The problem itself they given a value is less than 1 or mod a is less than 1. Formula: summation n equal to minus infinity plus infinity. Given signal a power n u of n e power minus j omega. This u of n will decide the lower limit. If it is a plus n, the terminating point is a plus infinity. To find the starting value, we have to equate n greater than or equal to 0. So that's why, so in the summation n equal to 0 to infinity a power n u e power minus j omega n. Now the summation is a positive, I'm going to convert this entire one as a in terms of something power n. That something is nothing but a into e power minus j omega whole power n. It is a standard formula. N equal to 0 to infinity r power n formula. Formula is first term. You put n equal to 0, something power 0 is 1. 1 by 1 minus this entire one. 1 minus e power minus j omega. We will see some more problems on DTFT. Find the Fourier transform of u of n minus 2. This is the finite duration sequence 2 power n u of minus n minus 1. First, given one is the Fourier transform of u of n minus 2 is equal to summation n equal to minus n plus infinity u of n minus 2 e power minus j omega. But we know u of n minus 2 is equal to 1 when this entire one inside bracket is must be greater than or equal to 0. So n minus 2 greater than or equal to 0. Otherwise its value is 0 when n minus 2 less than 0. So u of n minus 2 is equal to 1 when n greater than or equal to 2. Otherwise 0. That means u of n minus 2 equal to 1 from 2 to infinity. I am taking the 2 to infinity as a summation. So summation n equal to 2 to infinity, then u of n minus 2 will become 1 e power minus j omega n. Now the summation is positive, n value is a positive. I am going to convert this one as in terms of a something power n. That means summation n equal to 2 to infinity e power minus j omega whole power n. In the previous problem, the starting value is 0. That's why you got 1 by something. But in this case, starting value is at n equal to 2. So if we put n equal to 2, e power minus j omega whole square plus n equal to 3, e power minus j omega whole power 3 plus dash up to infinity. Then what is the formula means? That equal to first term by 1 minus second term by first term. First term means e power minus j 2 omega first term. Second term is e power minus 3j omega. So first term by divided by 1 minus e power minus 3j omega divided by e power minus 2j omega will become e power minus j omega. This is the Fourier transform of u of n minus 2. Next one, x of n they given 1 comma minus 1 comma 2 comma 2 means this is the finite duration sequence. So finite duration sequence, in this case they are not given any arrow mark. They are not given any arrow mark, we can assume n equal to 0. So the given sequence n starts from 0 and ending with 3. That means when n equal to 0, x of 0 1. When n equal to 1, x of 1 is minus 1. When n equal to x of 2 is 2. N equal to 3, x of 3 is 2. That means n starts from 0, ends with 3. So the summation is in general n equal to minus infinity plus infinity, because it is a given sequence, the finite duration sequence. N starts from 0, ending with 3. So this n equal to minus infinity plus infinity will become as a n equal to 0 to 3, because n starts from 0, ending with 3, n equal to 0 to 3. Now I am going to put n equal to 0. When n equal to 0, x of 0 e power minus, when n equal to 0, then x of 0 e power minus j omega 0, because it is summation plus when n equal to 1, x of 1 e power minus j omega into 1. N equal to 2 plus x of 2 e power minus 2j omega plus x of 3 e power minus 3j omega. Now replace x of 0 value. X of 0 value is, when n equal to 0, x of 0 is a 1. Now x of 1 value, when n equal to 1, x of 1 is minus 1. When x of 2 value is 2. X of 3 value is plus 2. This is the Fourier transform of finite duration sequence. Last one, they given Fourier transform of 2 power n u of n. In this case, the sequence given sequence is a 2 power n u of n is not a absolutely summable. That's why the Fourier transform does not exist. We'll see the solution. So to exist a Fourier transform for any signal, we have to satisfy summation n equal to minus infinity plus infinity mod x of n value must be always less than infinity. That infinity may be positive value, or that less than value may be positive value or negative value. Then only Fourier transform exists. So summation n equal to minus infinity plus infinity 2 power n mod u of n mod. Because of u of n starts from 0, n equal to 0 to infinity mod 2 power n. Replace n equal to 0, 2 power 0 plus 2 power 1 plus 2 power 2 dash dash 2 power infinity. If we add all these values, we will get the result as infinity. Because result is infinity, the Fourier transform does not exist. That's why if it is a Fourier transform of a power n u of n, will give one condition. That condition is a is always less than 1. But here a is 2. That's why Fourier transform does not exist. Next one, find the Fourier transform of u of minus n minus 1. Because in this case n value is negative, the terminating point is my starting point is a minus infinity. To find the terminating point, we have to equate that one to 0. We'll see. Fourier transform of u of minus 1 minus n minus 1 equal to general formula minus infinity plus infinity, given signal e power minus a omega n. So to find this one, so because u of minus n minus 1, its value is a 1, from minus infinity to minus 1. See, we know u of minus n minus 1 equal to 1 when inside value is greater than 0. Minus 1 minus n minus 1 greater than or equal to 0. Take minus as a common, then minus of n plus 1, send that minus to the right side, then n plus 1 less than or equal to 0 or n less than or equal to minus 1. That means if n is a negative, starting point is minus infinity. To find the terminating point, we have to equate the inside must be greater than 0. So I got n equal to minus infinity to minus 1 e power minus a omega n. Now I am trying to convert the summation as a positive. For that one, I am going to write the given sequence as a summation n equal to plus 1 to plus infinity e power minus a omega into minus n. Then that equal to summation n equal to 1 to infinity e power plus j omega n. So summation is a positive. I am going to convert this one entire one as a something power n. So n equal to 1 to infinity e power j omega whole power n, that equal to first term e power j omega by 1 minus second term by first term. You will get e power j omega. Thank you.